Hello guys, welcome once more to Class Online. My name is Mr. Jamb, and in this edition we shall be looking at Jamb Physics 2011 question number 26 to 30, and we shall be taking very sensitive aspects of physics in this edition that many students find difficult, and we shall be simplifying it in a way that you can understand and anyone can understand. Now don't forget that if you learn something from this video, click on like button. We have a lot to share with you that will better help you understand physics. Now let's get to the question now. A length of wire has a frequency of 250 Hz when stretched by a force of 225 Newton. If the force increased by 324 Newton, what is the new frequency of vibration? Now this question is simply an interplay between frequency and tension. That force is not just a force, that force is simply tension. And that is it. So now what is the relationship between frequency and tension? If you don't know that, then you can't answer this question. Now here is the answer to that question. F is directly proportional to tension. That means it came from this formula. It is all under spring, motion of spring, okay, under extension or elasticity of spring. This relationship came from this formula, that frequency is directly proportional to the root of tension. Okay, and that will be, this is very, very important to be remembered. So we've got to remember this now. Now, I guess next time. Now, this is now going to become, this proportionality symbol will become equals to constant root of tension. Okay, then I'll now make the constant the subject. So that means the constant will now become frequency divided by the root of the tension, right? Then from here, you can split it into one or two, since we have double of tension in the question, and then we have to find the second frequency. So I will say therefore F1 over T1 root T1 equals F2 over root T2. Okay, so I'm finding T2, that's the second tension. Now if I cross multiply, I'll be getting this is therefore going to, so I'm finding the second frequency, right? Now that's F2. Now I plug in the values. F1 is 255 divided by root 225 equals F2 divided by root 324. Now 225 remains the same. The square root of 225 is 15 equals F2 divided by the square root of 324 is 18, and that is it. So if I cross multiply, I'll be getting 15 F2 equals 225 times 18, and that will give me, if I divide by 15, I'll be getting 225 times 18 divided by 15, and that will give me 270 Hz. And that is the answer to the question, 270 Hz. Unfortunately, the answer to that question is not in the option, but this is the right answer to the question. It is simply 270 Hz, and that is the way to go about solving the question. Let's check out number 27. A certain far-sighted person cannot see objects that are closer to the eyes than 50 centimeters clearly. Determine the power of the converging lens, which will enable him to see, okay, at 25 centimeters. Now, whenever you hear the word power is the inverse of focal length. Now, that means I must find the focal length and invert it. So this is what to do. Now, you have been given two different, you have been given the object distance, I have been given the image distance, right? Okay. Now, the guy, now from the, so the first thing I must know that power is equal to the inverse of F, or focal length, and using the mirror formula, 1 over F equals 1 over U plus 1 over V, where my F is my focal length, my U is the object distance, while the V is the image distance, right? Now the object is at 25 centimeters, while the image is at 50 centimeters. So therefore I'll plug it in. 1 over focal length, I'm finding focal length first. 1 over focal length is therefore 1 over 25 minus, why minus? Because of the kind of lens, okay, and it's a converging lens. If it is a converging lens or a convex lens mirror, then you have to use a negative sign. If it's a converging lens, you have to use a negative sign. That means this positive sign will change to negative. This is called the mirror formula. But if it is a converging question, a converging lens question, you have to use minus, and that is the answer. So that's what to do. So I have 1 over 50, and that's what I have here. Then the LCM is there for 50. Then 25 in 50 is 2. 2 times 1 is 2. Minus 50 in 50 is 1. 1 times 1 is 1. 2 minus 1 is 1 over 50, and that means that my 1 cancel 1, my focal length is for 50 centimeter, right? Now, if my focal length is 50 centimeter, I have to change to meter. So I have to divide it by 100, because 100 centimeter make 1 meter, and that becomes 0.5 meter. It's now perfect. Now, but what is the power? We are not told to find focal length. We are not told to find focal length. We are told to find the power. And therefore, what's the power? The power is now the inverse of the focal length. That is 1 divided by 0.5, and that is 2 diopters, and that is the unit of lens power. It is in diopters. So the answer is simply 2 diopters. Don't forget that I saw everything from the mirror formula, got my F, and the inverse of my F is my power. So power is the opposite or the inverse of focal length, and that is the answer to that question. It is 2 diopters. It is simply 2, not even 0.02. It is simply 2 diopters, and that is the answer to the question. It is not C. It will have been closer to D. Closest to the answer is just D. Okay, so it is naturally supposed to be 2 diopters, and that is the answer. Which of the following electromagnetic wave has the highest frequency? Come again. Which of the following electromagnetic wave has the highest frequency? Is it infrared ray, X-ray, ultraviolet ray, or radio wave? Now, which one has the highest frequency? Do you have any idea? Now, you know that all these rays, all these waves are all electromagnetic waves, right? And that means that they don't travel, they travel through no medium. That means they don't use medium to travel. Okay, now there are 6 electromagnetic waves or wave given by the formula Revox G. Okay, those are the 6 major. Okay, but there can be more, but majorly we were taught 6. Okay, Revox G, right? Now Revox G means R is what radio, like we have here. R is radio wave, then I is what infrared, V is visible light, ultraviolet ray is next one, O is ultraviolet ray, X is X-ray, and G is gamma. Gamma ray has the highest frequency, and the frequency decreased down to radio wave. The gamma ray has the highest frequency, but radio wave has the highest wavelength. Okay, so now gamma ray has the highest frequency, but on the list you don't have gamma. So the next highest is less than gamma, but the next highest is X-ray. And on the list, do we have X-ray? Yes, we have X-ray. So frequency decreased from what gamma ray down and down and down. So the highest frequency on this list is simply X-ray, since gamma ray is not there. So the answer is what? X-ray. It is by the Revox G formula. You know, Revox G is all the electromagnetic wave. Okay, but the highest length belongs to radio wave, while the higher frequency belongs to gamma, the end. So, but if it comes to frequency, it will start sloping down. So the next highest is what? X-ray, and that is the answer to that question. You must know that Revox G. It will help you to get the one with the higher frequency and the one with the higher wavelength, and that is the answer to number 28. Number 29 says, when a red rose color is observed in blue light, what color does the observer see? This is simply a question on light colors. Okay, now you do know that light has primary colors and secondary color, and we have tertiary colors. Unlike in fine art, we deal with what colors also, but it is not the color of pigment. It is the color of light. So the primary colors of light are simply given by this. The primary colors of light are green, red, and blue. This is called additive color model. Okay, green, red, and blue. But you will say this is not the primary color. Yes, in fine art, we are not dealing with light color. We are dealing with pigment or paint color. In the world of art, the primary color are yellow, red, and blue. That's magenta and blue. Yellow, red, and blue are the primary color. But in light, in physics, in optics, the primary color are green, red, and blue. Please take note. Now, the question says when you combine red. Okay, before I go on, let me mention the second color. Second color are yellow, cyan, and magenta. Okay, and if you fuse all the color, it will produce white in the middle. Okay, now when you combine red color, that's the color. The question says when you combine red color with blue light, what will it give you? Blue and red will give us what? magenta, and that is the answer in the middle right there. Blue and red will give us magenta, and that is the color. So the answer is simply magenta, and magenta is the secondary color between red and blue, and that is the answer. So please note that you must understand that you must notice this color and you must be able to differentiate them. Red, green, blue are primary, but the combination of green and blue will give us cyan. Combination of red and blue will give us magenta. Combination of green and red will give us yellow, and that is the color of white light. Those are the primary color and secondary color of light, and that is the answer for number 29. Number 30 says the ellipse of the sun occur when the what? Is it when the moon is not completely hidden its earth side shadow? When the moon is unimbra falls on some part of the earth, the moon is between the sun and the earth. When the earth is between the sun and the moon. Eclipse of the sun. This is actually very simple. This is actually a basic 6 question because they were talking about eclipse. Now, eclipse happens when the moon is in between, when the moon is blocking the sun. And the reason why the moon can block the sun is because the moon is standing in between the sun and the earth. And it will produce two shadows. It will produce a perfect shadow called umbra, and it will produce a semi-dark shadow called penumbra. So we have the umbra or very black shadow. At this point, if you are living here, you will not see clearly. But at the second point, it will produce a penumbra shadow which can see a little. And that means that the answer to that question is when the moon is in between the sun and the earth, it is an eclipse of the sun or a solar eclipse. And that is the answer. But notice it produces two shadows. Very black shadow called umbra, in case you were asked next time. And the semi-dark shadow called the penumbra. And that is the answer. It's happened when the moon is between the sun and the earth. And that is the simple answer to the simple question. And that brings us to the end of this video. Don't forget, if you learned something from this video and you want to get more content, click on like button. We have a lot to share with you that will better help you understand this. Until we see you guys, take care of yourself and bye for now.